Right, picking up with our linear functions here. Number 11, determine the equation of the line passing through the point 5, comma, -2 with a slope m of -8. Put the equation in slope-intercept form. And so once again, that is y equals 2mx plus b. I know my slope already is -8, the m, so I just have to find out, well, what's the b? And I can use these values to figure that out. So my x is 5, my y is -2. So if I plug in those for x and y and -8 for m, I'm essentially working with -2 equals -8 times 5 plus that b value. Again, just plugging in for x as 5, y is -2, and m is -8. So I'm going to get -2 is equal to -40 plus b. I can add 40 to both sides. These eliminate, and so I've got -2 plus 40. That tells me b is a positive 38. So I've got y equals to -8x plus 38 as my linear equation. Number 12 says, give the equation of the line perpendicular to y equals -1/3 x plus 2 and passes through the point 5, comma 1. Again, put the equation in that slope-intercept form. So I'm looking at y equals mx plus b. Just like in the previous example, I've got x and y. X is 5, y is 1. Because my line is perpendicular to this line, remember, parallel lines have the exact same slope, but perpendicular lines have slopes that are opposite reciprocal. So my slope is going to be a positive 3. Where the original slope was negative, our slope is the opposite, so it's positive. And the reciprocal, where this was 1/3, our slope is 3/1, which simplifies just to be 3. So I can plug in 5 for x, 1 for y, and 3 for the m, and solve for b to get my y equals mx plus b form. So I'm going to look at y equals 3 times 5 plus b. So 1 equals 15 plus b. -14 is what my b value is. Just take away that 15 on both sides. So I'm looking at y equals to 3x minus 14. And this takes us to our last page. Number 13, the graph below is a transformation of the original function f of x equals x squared. Write an equation for the function graph below. We'll call the new function g of x. We're going to say, well, what is g of x in this case? So the original x squared is this parabola, but it starts at the origin and it goes to the point -1, 1, and 1, 1. So it looks like it's the same graph, but it's been shifted to the left 2 and then up 1. So I could say g of x is equal to, inside my parentheses, I'm going to say x plus 2 squared plus 1. Remember that what's inside your parentheses moves the graph left and right. So when I work with this x plus 2 in parentheses, I'll pull this out as a -2. So this is going to shift left 2. And then what's outside the parenthesis moves your graph up and down. So to move it up 1, I would just put a +1 on the end for that shift up. And you could double check. I mean, you've got some points here. So if you plug in -2, it should give you 1. If I plug in -2 for the x, -2 plus 2 is 0. 0 squared plus 1 is still 1. It's like you've got -1, comma 2. So if you plug in -1, -1 plus 2 is 1. 1 squared is 1. Plus the 1 on the end gives you 2. So -1, 2 works out. So there's no stretch. There's no shrink going on here. Similar idea, number 14. We just don't have the graph. So write an equation of the function g of x. That is the graph of, this should be f of x equals to the absolute value of x. Shifted right 4 units, shifted down 3 units, and reflected over the y-axis. So we're just going piece by piece. So g of x is equal to, so if I want to shift something to the right 4 units, left unit, that's inside the parentheses. So I'm looking inside my parentheses. X minus 4, right? I would pull that as a positive 4, so that would shift it to the right 4. Shifted down 3 units, up and down is outside the parentheses, so a minus 3 outside. And then reflected over the x-axis, reflected over the y-axis. Reflected over the y-axis, well, here's your y-axis on any graph. You're going from the right-hand side to the left-hand side, or the left-hand side to the right-hand side. So you're flipping from left to right or right to left. So that negative that does your reflection should be within your function. So this is still an absolute value. I'm just going to throw a negative inside that function of the absolute value, so it's with those parentheses there. So the negative inside the absolute value inside the function is going to shift it from, not shift it, but reflect it from left to right or right to left. The minus 4 within the parentheses inside the function is going to shift it right. And then the minus 3 on the end is going to shift it down. For number 15, for the following, determine whether the graph is symmetric to the x-axis, y-axis, the origin, or none of these. This ends up being none of these. To be symmetric to the x-axis, which is this axis, what's above it has to look like what's below it, but this little sliver doesn't look like all that's below here. It almost looks symmetric to the y-axis, but you've got this curve here. To the right of that, you would need another curve mirror imaged on the other side, and it's not there. And then to be symmetric to the origin, you need the diagonals to have that symmetry. And there's no diagonal symmetry. There's no symmetry in this original graph. And the final one of the review, find 2 non-trivial functions. So you've got f of g of x. G of x is your inside function. It's inside that function, f of x. F is your outside function. And so inside parentheses, you have 2x minus 1. So g of x is 2x minus 1. Outside of the parentheses, you have a squared symbol, so that's your f, that's your outside, and it's f of x, so you would have x squared. So if you plug g of x into f of x, you would just have 2x plus 1 squared, which is exactly what we have here. And so this wraps up our test review video. Email me if you have any questions. This is essentially what you can expect on your test for test 1 in this class.